Hello. We're gonna have a stream after a long while, and I have a new stream platform also I'm testing. It's called kick.com, and it seems to be some kind of Twitch copy, basically. Not as popular, but I figured that it would be quite a easy thing to test it out.
Other people to bits.
And yeah, I'm a little bit playing around here, seeing if this stuff works and whatever. Wait a minute. Not here. Okay. So what are we streaming today about is we're gonna try to see think about what would be fair contributions to the from different countries to stopping climate change. And I think this is part of my process to update my website globalcarbonprice.com. I kind of want to have the extension to the site that is showing I want to show like if you don't have this global carbon price system, what would be kind of like yeah, fair how would the countries per capita emissions evolve over time and compare to this world per capita emissions. And this would be kind of like you could have like this two-part deal where some countries they take part in this deal of accepting this global carbon price, and then starting to price their emissions, but it could also be possible to just kind of like agree that we are doing our part of this emission reductions without submitting to this global carbon price scheme. So you could opt into this kind of agreement on what you're doing, but then it's a interesting question, like, because with this global carbon price, each country's per capita emissions, they would be defined by how much those people are willing to pay for emitting carbon, and then we would balance it out by distributing the revenues from carbon pricing as carbon dividend, as I have on my website, this kind of system. But if you don't submit to this kind of thing and you want to have this fair carbon pricing or like this fair contributions from each country to stopping climate change with whatever the budget is, then it's a lot trickier situation, because then you really have to make this deal on how much your country should reduce emissions, and there you can like calculate the average emission reductions. And so here the system is, you have this kind of convergence thing that I have explained here in my this like notepad thing here. I think I should maybe make this a little bit more, this formula maybe a little bit more readable. Okay, I think I'm also using a little bit, maybe not, but this is basically the formula like with, and this is more like a prediction than anything fair. Like this is kind of like hypothetical prediction on how the emissions could develop over time with this system. So we have this how this system works, and this could also be used. Like this is a very like rough, assuming like that there's convergence in per capita emissions. So the convergence means that like emissions between countries, they will get closer to each other over time. And I think there's been like some, I think the general trend is towards that direction. Like I think I should still like maybe calculate based on all data on like how great the convergence has been, but there is some level of convergence between the countries. But here, if you set like this COB, I think I should use maybe I'm gonna change the notation here. Instead of this OBS, I'm gonna use N, so that means end year emissions, which means like emissions at carbon neutrality year. So here, so we have country per capita emissions at carbon neutrality. Yeah, it doesn't really fit. And this is the formula for calculating, and it's a basis of the formula is the global average. So what would be required? So if we go here, I think it shows a little bit small now. Let's see. I don't know how is this gonna get messed up because I try to make it bigger. And my website is technically very clumsy, I'm gonna say that. So here we have this kind of emission path like for global emissions, then we have the population projection, and then we have this mean emission path, which is calculated by dividing these total emissions with the population for each year. And now here, for example, we have mean emissions of we have like 1.3 like here, when there is 1.3 tons of CO2 with default settings at globalcarbonprice.com. So that would be kind of like the basis where we start calculating and so that's like defined first on like what do we need to stay in our chosen carbon budget here. So then we have this thing that we have this convergence thing, And we maybe first start by we have this comparison of let's see. Yeah. Yeah, this is basically like how much the emissions have to be reduction in kind of like in percentage term, and this is how much the world emissions are higher than the country specific emissions at the beginning. So this sets kind of like your distance. So let's see. We have here, I'm gonna use some other little bit different color here. Maybe here I can look a little bit different. So let's say we have the world emissions here, where we need this kind of reduction, and then we have the country specific emissions here, and this is like the start year here, and then we have here, or maybe we put it here, start, and then we have the end year here. So we need this kind of reduction in total. But so this here now is the, so here we have a C start, and then we have here W start, like the world starting point, and here we have like this kind of like difference between those, which is this number here that I've highlighted in the notepad. So that's kind of like so we kind of keep this, and this is now in terms of kind of like, wait a minute, let's see. I think this formula could be better actually. I'm gonna write it a little bit different here. So we have so I'm gonna put this one here. So now we have this. So this is the difference now in percentages of the country's emissions to the world emissions. Let's see. We're gonna check out some stuff here. Okay, so and so now that we have it here, so we start from here, we have this W end here. So we start here and then we add up like from to this, like so this is now like we make it so that it's higher. The D stays same in like percentages. So if you have here, like let's say we have 5 tons here for world emissions, and then we have like 5.5 tons here, and then we have 1 ton here for world emissions, then we need to have 1.1 tons here. So the percentage change stays the same, or the percentage difference. So we would get a little bit like this kind of path. So this would be kind of like without this conversion. So we are assuming that like the distance for each country remains the same, like in terms of percentages. So the absolute difference would be reduced in case of these. So let's take another example. Like we have like we have 1 ton people here. So this would mean that there's like these are like 80% smaller. So this would be like 0.2 tons here. Basically this. And it would have like this kind of path. So, but this would be a little bit unfair maybe, or like it would be quite hard, like because if every country kind of has to reduce the same percentage, which is what this basically. Well, okay, yeah, I think so. Yeah. I'm not sure about that actually. Is this equal to each country having to reduce? Yeah, I'm not sure if that's actually correct, but I think it might be. So there would be this reduction percentage for each country. Yeah, I think it could actually. Would it follow from this? Let's see. So I'm just gonna make a note. It's 3 also reduces by equal percentage. There's also like one more way to make this more simple. So we have so we would have 1 minus, and then we just take this out from here. I think this is like a one way to like that. One minus. So if we have here 0, this goes to 1, and then we have a difference. Let's see, 1 minus. Let's see if this is correct. So if we have like a country with like a smaller emissions, minus, yeah, this would go like 1 minus something smaller than 1, and if we have a country with larger emissions, yeah, this could at least the direction is correct. So here maybe have like another set of parentheses to make it a little bit more, and maybe make this kind of like thing to make it clear that it's good to think of this as a one chunk of stuff. But I'm not sure if this is like the best way to think about this or not. Or would it be best to think about it like something like this, so that we have what if we bring this one to the front? Like, I'm thinking like what are the best ways to think about this. This could like in the end, I don't know, be the best way to do it. I'm not sure. Yeah, and then we have this convergence thing that the greater the convergence, the smaller is the weight of this latter part here, and it means that if we have a convergence of 1, then the emissions at this year and here they will all be equal, so they will converge until that year, until they are equal. So, and then it's a little bit tricky, like how do they converge so there's some, it's only a little bit different. Like even if it's equal here, there is still gonna remain this inequality before this end year, and so in this carbon dividend system, this carbon price and dividend system, this equality is kind of like compensated by so if these emissions remain high, this means, let's see, so this means that there will be like a net payments, and here if you are under the average in world emissions, then we have here the net receivers, but this is only the case for if we have this if the countries commit to this global carbon price and dividend system. But now I'm thinking like if they don't commit to this system, but if they only commit to this common carbon price and there are no transfers basically from rich countries to poor countries, then how so don't commit to pricing and dividend, what would be fair country specific paths for stopping climate change. So I think here we have some options. So we have same as above, use predictions to calculate, but that's not like very fair. So at least like also like I think what would make it maybe with 100% convergence by neutrality year. So the next option, not gonna. So another option is you have a equal carbon budget by carbon neutrality year for each person. So what this would basically mean, like so for example, these guys here, everyone would in the start date of the system, everyone's emissions would be allowed to be here. So regardless if you have like 10 tons before or 1 ton before, everyone is allowed this 5 tons emissions and so on. But this is like, of course, like not very, this is very like it's a kind of like a version of this system where everyone can adjust immediately, but there's another also like that. So you would have this area here, like the emissions over time, everyone would have to have this to be equal. So how could that work is like that these rich guys here or these high emission guys, which is through correlation usually also like the rich guys but these guys they could have like their higher emissions at first, but then they would go like this, they would go here and something like this. So they could actually like maybe end up being lower in emissions than the poor guys. And the poor guys, they could have like something like this, where they like they could increase their emissions and then maybe go like this. So yeah, this is another option, and I'm thinking like maybe to even make it let's make this a little bit cleaner now. I'm thinking like we could take into account here that, so let's clean this up. I think we need any of this stuff necessarily. So how this could, if we want to keep it the idea that we have so this is the let's see, world average. And now we have this. So we could keep up with the idea that we have this 1 ton, for example, for each at the final year, at the carbon neutrality year. So how would that work out here? So that could mean that we have a similar kind of like stuff. You go through here and then you're gonna like go like this. You go faster to the reductions. Something like that. And this guy here is allowed to have something like this. So we just have to look at that this area here. I'm not sure if this is realistic, equals this area here. So you are above the global emissions for the same amount as you are below the global emissions. I think this could be a little bit problematic in like, do we want to set some restrictions that for each year, like this year here, do we want to keep this annual emission path as it is, or so that because there could be the case that for the global average we see something different, so we could get a little bit different path than we have envisioned here. And I'm not sure if that is a problem. It could be a problem because of there are like there are those non-CO2 emissions, they could be tricky with this kind of system, because there's this dynamic that they have this compared to like CO2 emissions, which kind of like adhere to this kind of carbon budget thinking. Those non-CO2 emissions, they kind of like have this time dynamic on how much they warm the atmosphere compared to when they are emitted. So for methane, for example, like when it's released in the atmosphere, it has a instantly like very high. It warms the climate a lot in the first years since it has been emitted to the atmosphere, but then it quickly decreases, and for CO2 it kind of like it stays pretty much constant for any meaningful time period. So that's a big difference there. And yeah, so then that's why like and these kind of like paths might be like a little bit like calculated based on like the combination of those, and if the combination doesn't match anymore, and like yeah, I don't know, it's a little bit tricky topic, but I don't think we would be too far off, but just like so what's a little bit tricky about this stuff is that are these kind of like paths, are they very realistic? So that we have a reduction, like this massive reduction here in the high emitting countries, and then there's increase in low emitting countries, and this is of course like partly like the convergence in the standard of living, in your ability to consume and produce emissions. It kind of like leads to this way, but I don't think the effects are so strong that it would actually lead to, like, even if this 1 ton country here, let's say like Kenya or something, I think their emissions might even be lower if you're talking about CO2. Let's say they have this kind of path here and we have like a Finland here or something. Even if they're like allowed to have this kind of emission path, I think it could be even more, it could be better than this in a sense. So this is not fair. So they could of course be like some kind of, so we could have like an intermediate between this global carbon pricing system, which is directed towards individuals, but we could have this kind of intermediate thing where the countries switch between their targets, so they keep like, they would like sell their, so here we have like this kind of part here. So let's say like that the Kenya, they could easily have like this kind of path, so they have this excess here, so they could decide to sell it to this rich countries, let's say Finland here, and the Finland could then have like this kind of path where it uses that excess compared to like how much it's allowed to emit there. So this kind of deal could happen, and of course it could happen already here, like instead of this kind of like reduction here, and then this could be allowed to emit a little bit more. But maybe this kind of maybe this could be like a one it's a one form of doing a global carbon price, is not to have it as a tax, but to have it as a budget for different countries. And this would then there's these arguments of also like like another system is like take historical emissions into account, but I'm a little bit skeptical about this one. They are yeah, I'm not sure like how well they would work out. Here I'm thinking like I could calculate like I could use this like the already existing like math in the page. Like if I do this convergence thing, for example, and like make it so that like I could speculate. You could use it to speculate on how the countries will how the countries would what would be the most efficient way for countries to reach these goals or like their own targets, like how the transfers of these emission rights between countries would be sold out. Yeah. And yeah, we are in European Union. We are basically applying this kind of system at the moment for emissions in emission reduction sector and the land use sector, but those deals between the countries, like or like they don't have the countries. Let's have another layer here. Let's have some countries, and they have like some emission goals. Like here, you have two countries with their emission goals like this. There's no like here we have like 2030 and like 2020 or something like that. So countries, their emission goals, they don't, there's no like equality or like they don't kind of like assume that the emissions would be equal by X. But of course they could I wonder if we could have by 2040, could that be like what are the emission targets per capita? So let's think about this could be a topic for a video actually. So emission targets per capita by year. So if you have this kind of graph, so I could like I could plot all the EU countries on like what kind of goals they have, and I think like for EU, like one big defining thing there is the what impacts these targets is the GDP. So countries with higher GDP, they have like a higher reduction targets, but they also have like a higher emissions also. So that's kind of like fair. But I think so if we have like let's say we have average here. So I think there's there's already like, I think like for Finland, for example, we have like our target is I think it's already like it would lead to below average emissions at the EU level. So I'm kind of like thinking that if we have this system in place in the EU, then we could expand it to the whole world, but I think then it's still a little bit like issue of defining like what are the fair emission goals for each country, and I think that's a very tricky because I think there's also a lot of that is also about that countries, like some countries are more keen to do climate action than other countries, and I think those countries in the EU, they are given a little bit stricter, or they kind of like in these like negotiations in the EU, like those countries, they accept deals that are more stringent for them. They are like, they are ready to take a greater share of the emission reductions, like compared to what it would be based on like some per capita or like emissions per capita or GDP per capita measures. But it could be like I'm still thinking like, could it be like politically easier actually? Let's have another graph to have so let's see where we are going. No. So EU is about to decide on the 2040 targets. So let's say we are now 2024, and then we have 2030 here, and we have, let's say we have this kind of like EU ESD per capita emissions here. So let's say EU has this kind of path now for 2030, and then we are gonna set, okay, I think it's gonna be like a straight line pretty much, and then we're gonna set the 2040 target, and it might be pretty similar. These are not in scale now, but so let's say we have this kind of targets, and then we have those country specific that so we have like this kind of stuff here, so that on average this will always like count to this, like these blue lines for the countries or the member states in the EU. They sum to this EU target. So now I wonder that, do we want to have for 2040, would it already be desirable to have so that we could have like a total convergence in targets over there. So each country would be in 2040 would be allowed equal emissions, and before that, like the intermediate years between 2030 and 2040, they would also be like intermediate in terms of policy, so that those countries that have higher targets in they could like in 2025, 2035 they could already also have like higher emissions, but over time we would reach this convergence, and for each year the countries could sell their emissions targets, or like if they have if it's difficult for them to reach their targets, they could buy these quotas for countries for which it is easier. So let's say that these blue lines are now they are the quotas. So, but let's look at, for example, this country here. So let's say that it's not so easy for this country to reach its targets, so it goes a little bit above, but now for this country it is easier to reach its target. So there's this small array here that this country can sell to this country, so that the average still stays. So this is what's happening now. Like this is already a policy in the effort sharing sector, which is about half of the emissions, and it's basically the opposite of the emission trading sector. Even though there's like there is now this and then there's the LULUCF, the land use sector, as a third sector, but now basically this emission trading has come from the emission trading sector to the effort sharing, or I don't know what, there's some other term also for this, but for this kind of like residual sector already. And yeah, so countries are already doing this, and I think it's gonna get I think in the next few years they're gonna like decide on what's gonna happen here from 2030 to 2040. Like from now to 2030, I don't think this is not gonna be they're not gonna touch this section, but this one there's gonna be, this is where the policy changes are gonna come, but they're not gonna, because for 2030 and before that, like it's too short time to negotiate, and for the policy to, like, it would be too short time for everyone to prepare for the new policy and the new incentives and stuff like that. So it's not efficient to do changes for the 2030, and I think like the 2030 targets themselves, they are pretty okay. I don't think there's like a but I think like it's a big thing on how to get an agreement on this total 2040 target that we are gonna get here. Let's say like 500 megatons of CO2 equivalent. Like it has a lot to do with what's acceptable to the countries, and I'm not actually now quite sure like what's the, so this is negotiations between European Parliament and the member states, and I'm not sure about like regarding member states, like does this kind of decision, does it require unanimity? What's like that? Does it require that all the countries agree on the deal, or is it enough that some kind of like, I think what they call like a qualified majority, is that enough for the deal to go through? So I'm not sure about that, but that could have quite a big effect on the acceptability. And but I think like what also would be interested in these terms of acceptability is the simplicity, and this would increase the simplicity of the climate policy, and I think that would be a very like very enticing thing for climate policy to have. And also like now some countries often, or maybe not countries, but like the citizens in some countries are like arguing that okay, we got the bad deal here because it's so difficult to determine like what's a good deal. So, and this is probably not like this would not be the fairest deal, but it would be kind of like if the deal is simple, it would that would be like one. It would help it a lot, I think. I did some kind of calculations at some point, like how much are different countries. So how much they are like reducing their emissions and stuff like that. So I wonder if this kind of graph would be helpful, and would it be fair? Yeah, no. And of course, like some countries, they have like very different industries and like different climates and different situations. So I'm not sure if this can be considered fair. I think I probably like should look into this. But here it could also be that, I don't know. I'm like thinking like it's gonna be that it's a little bit different in Europe than in the world, in the sense that in Europe the poorest countries per capita, I think they are often very high up on the list, because the rich countries in Europe, they have pretty much like, there's more of this transition to this kind of like service economy and stuff. So what it means is that these countries, so it's kind of like that the poorest countries are maybe more industrialized, and they have lots of agriculture, which also produces lots of emissions. And I think in general, like they have a like higher, like the relation between GDP and CO2 per capita it could be even inverted, but this could be so this could be something And this could also, like, instead of 2040, we could think this as a time scale of 2050, when the EU has a carbon neutrality target. So I think that could be quite more enticing to calculate, like how much emissions can we have left until 2040, and if in 2040 we would have kind of like equal emissions per capita. Yeah, because like my idea, like I think like 30 minutes ago or something, was that EU could be an example of where the emissions reach this global average, but it's but it's so much easier in global sense, and I think only on average, because the lowest emitting countries are the poorest countries, and they would benefit from these transfers from purchasing these quotas. But for European Union, it's a lot trickier. Because the monetary transfers would go like the other way around, that they would go from the poor countries to the rich countries quite often. So that would be tricky. But now I think, like, if we keep up with this thing that your emissions or your emission quotas are based on your previous emissions in a manner that you're like you might get this incentive to keep your emissions high, at least to some degree, because then you get higher emission quotas in the future. But of course, like there's also this yeah, that could be interesting thing to research, like I don't know. Okay, I think I'm gonna end the stream, and maybe I'll have another stream when I have I'm thinking, like, what do I want to do next? Like, do I want to look into these EU things, because it's an interesting thing, and I think it could benefit, like, for the general public to know, like, where we are going at the moment with these targets. I think kind of like the importance of that also depends on whether or not that is applicable to the global scale, like whether I want to move this my carbon price project to be more about the countries, like consider more about countries than about than it is about okay, I think I'm gonna end the stream now anyway. Thanks